going on the event. We will be talking about the future of AI-driven mobile applications in general, and specifically about mobile nutrition and fitness applications. So as all of you are seeing every single day right now, we are entering into a very, very exciting new world. The world where AI is a big, big part of everybody's lives. And for all companies and for all developers building the future, AI is no longer a nice to have. And for all of the businesses entering the world, for businesses that are selling products, marketing products like supplements, selling food delivery, providing services like nutrition services or healthcare services, AI is no longer a nice to have. Every single business will need to have dedicated AI assistants, AI chatbots, representing the business, servicing customers, serving as extensions of all of our businesses. Every company that we talk with, they are gearing up for this future, and they see this future coming. So, for example, in every nutrition clinic will need to have an AI representing that nutrition clinic and interacting with customers when doctors are not available. Every company that sells supplements will need to leverage AI to personalize those supplements for their members. We, as a company, so Passio, we are building an omni-channel future where we support service businesses like nutritionists, doctors, clinics, health insurance organizations, and fitness applications, fitness coaches. We also support companies in retail. And for example, we've got a use case where some of our customers have apps and have websites that sell, for example, physical goods and physical products like furniture and paints. And right now, it's no longer enough for them to have a physical store and to have a web application. They need to have a fully immersive AI-powered mobile apps. And this is the future where every application, successful application, will have an embedded AI agent and will have computer vision and ability to personalize for their users. It's no longer nice to have. Customers are starting to expect this. And this is why we are developing Nutrition.AI. The way we are building it is to make it super easy for companies and developers to take an SDK and plug this AI into your applications so that you can go on day zero from not having an AI-powered app to having one, an application that you can point for that's got ability to recognize food, ability to provide personalized feedback, ability to listen to the customer in their own voice and to talk to the customer, ability to provide advice about what foods customers should and shouldn't be eating given their goals and given their conditions. So that's the future that we will present here and share many interesting features with you that you can start using today. And that took us many, many, many years to develop. And right now we're bringing them to you in one SDK that you can get up and running within less than a day. So here is a quick preview of these features and what's possible with our application. So we're developing this tool that allows full computer vision and logging of meals using computer vision. You can see here, we swipe phones over foods, and those foods are populated into the tray. So instead of users logging their meals with typing, users are now able to log their meals with just pointing phones at the foods, or as we will share a little bit later, users can log their food with voice, or by pointing at barcodes, or by scanning nutrition facts, right? It needs to be completely multimodal and completely intelligent. And this is why we're so excited about Nutrition.AI, because the technology like this has never existed before. Like, for example, here I'm pointing at Cheerios with milk, and it knows that it could be Cheerios with soy milk or almond milk. There could be sugar in this coffee. And we are providing with the SDK an easy way to create recipes, add invisible ingredients. The SDK itself thinks about invisible ingredients. If you were to build this technology from scratch, it would take years and years and years. And right now, with tools like this, you can see that it's becoming possible to embed something like this into your app within just a few hours. So these are some of the features that we will describe, and we'll tell you how we build them, how we personalize nutrition suggestions for members, and we'll share with you basically the full platform that allows you to use and get it up and running within hours. Obviously, we are also excited about this because people are using this. As many of you know, we've been powering, for over 4 years, we powered the largest fitness app in the world, MyFitnessPal. We've been powering Anthem, Blue Cross Blue Shield as a provider of their nutrition tracker technology. And we're honored to be powering many other applications across healthcare, fitness, and everything related to food, basically. This is where Nutrition.AI is used today. And this is where we are essentially trying to take this technology to the next level. So these are the features that we will be talking about. With the SDK that we provide, you can do volume estimation on device. It all runs on device. And this is kind of one of the key elements of the future of AI. We've all heard, and we are all using ChatGPT. We are all using diffusion models that run in the cloud. And those are giant and heavy models. But there is one major trend that all of us as developers need to be aware of. The world is moving to personalized on-device AI. And Andrew Ng, during his talk this year at the World Economic Forum, mentioned this. And many other AI leaders and pioneers are actively talking that this year, 2024, will be the year when AI is moving off of the cloud and back to the device to provide privacy, to provide ability to do real-time recognition with zero latency, and enable operation when connectivity is not there. So many of the features that we're describing, like volume estimation, scanning of foods, scanning of nutrition fact labels, recognition of foods, we're doing a lot of that analysis on device. And then we're only pulling nutrition information and the information that really does not belong to the device. We are pulling it from the cloud. But when we are building apps right now, AI-powered apps, we as developers need to be thinking about how can we distribute the compute so that the heavy compute, the AI inference, is happening on phones, inside of tablets, or inside of our augmented reality glasses. This is the new platform, the AR platforms that we will be using, obviously, for recognition, starting this year, but definitely in the future. And that compute needs to start happening on device. And we are already doing a lot. The SDK, all of these elements, so food recognition and volume estimation, all already happening is happening on device. So let's start by looking at examples. Imagine you're building an app that will help users to track their food, to track their nutrition. This is the magic. You start by pointing the phone at foods, and the SDK starts scanning those foods and adding them to the tray in real time. That's essentially the experience. And starting providing suggestions to users about what the alternatives could be, because very, very frequently we're pointing the phone at a food like mashed potatoes, and it's not obvious. Is it mashed potato or is this hummus and things like this? So we developed at the company, at Passio, we developed a lot of templates. So what you are seeing here is a template that we provide you with code, and you can modify it, that already solves the user experience. And this is kind of another learning for all of us as builders, as developers of the future, is AI itself is no longer enough. It's much more about user experience. How do you build user experience around capabilities that never existed before, right? We've never had that degree of ability of an artificial intelligence system. Now it can recognize every food. It can suggest you recipes. It's all possible now. And it was really, really, really difficult a few years ago. Now it's all possible within SDKs like ours. And it becomes all about user experience. And we provide you with that user experience out of the box. We develop many, many, many templates that give our customers easy ways to log their food and build AI-powered nutrition tracking, food recognition applications. So here you can see we recognize coffee with milk, and users can select this as a recipe and edit milk, change it from, let's say, 2% milk to soy milk. And then next time you're pointing at your coffee with milk, the recognition will be your personal coffee with soy milk. And if you add sugar to that recipe, it will remember that you're normally logging your coffee with sugar and soy milk as opposed to coffee with milk. Obviously, barcodes, this will continue to be the case. We've got integration with multiple databases, supporting logging of over 1.5 million foods, and that database is constantly growing. But imagine, for example, that AI is not able, that the scanner is not recognizing a UPC code. What do we do next? We can direct users to scanning nutrition facts, and they can log the food or create a new food just by reading what's on the package. And this is kind of the magic of AI today, is we're able to combine computer vision that recognizes foods, like here, right? We're recognizing raw and cooked foods. Here we recognize ingredients, right? We recognize ingredients. Here we recognize a recipe, which is coffee with milk. You can also point at other recipes like pancakes and lasagnas, and it will, or pies, like the Pie&AI, and it will recognize pies for you. But it can also at the same time recognize UPC codes, and it can recognize text on packages, and it does this in an intelligent way. This is essentially the game-changing capabilities that a few years ago were extremely difficult, and now it comes out of the box within one SDK, within one binary file that you basically, or a set of files that you can install and get up and running within just a day. So this is the first challenge that we're solving, is how do we support effortless food logging? But obviously, nutrition is much more than this. We need to start providing advice to users. We need to start understanding their nutrition. And this is other elements of our Nutrition.AI technology. And this is another component of why adding AI into apps and building new types of applications is so important. So if you are a doctor today, or if you're a dietitian or a physical coach that provides fitness advice to members, you really have to think about how do you scale yourself and scale your ability to provide advice and grow your business. The one-on-one consulting is becoming less and less scalable or less and less attractive option from the economics perspective. You need to augment yourself. You need to augment your members. You need to augment experiences of your members, increase engagement, collect nutrition data, and give your patients, your members, and the community you're serving new ways to engage with your business. And this is essentially what we support you doing, is building apps that essentially instantiate your business. Instead of just having a physical presence where you consult, you bring an app to your members where you can answer their questions with AI and scale. Instead of supporting 10 members, you may be able with AI to support 10,000 members, for example, by instantiating yourselves. So this is what AI-powered apps can do for you: improve engagement, help you collect reports and get visibility, engage with your members when you are asleep and or taking a vacation through AI, and really reduce the cost, because if you've got 10,000 customers and instead of 10, you're able to spread the costs and offset some of that cost, making it more affordable for your members. So obviously, with AI nutritionists, we're also able, the easier it is for patients to collect this data, the more value out of this data you as the company can extract. And this is another use case. So one of the use cases is obviously nutritionist offices and fitness coaches. Another use case is collecting data for pharma research. If it's very easy, engaging, and straightforward for patients to collect food data, you can build applications that collect data for clinical trials. Imagine, for example, we're doing a clinical trial of a cancer drug, and you've got a cohort of 1,000 patients, and you do not know what those patients are eating. Very frequently, foods have very deleterious effects on different drugs and different drug configurations. So if you know what patients are eating, you, for example, can determine that a small cohort was eating a lot of meat or drinking soy milk, and it negatively impacted the effects of the drug. This is a very, very valuable insight. If, for example, you build an app or you collect data in a clinical trial that leads you to discover that a new drug or a new treatment process by Roche or Novo Nordisk or Lilly is impacted negatively by a specific food or a specific diet, this is incredibly valuable and massively impactful on their business, and can be a phenomenal business for you. Obviously, the same with fitness coaching. Instantiating fitness coaches with AI nutritionists offers phenomenal opportunity. We just going back to the healthcare case, we asked in a survey, over 150 healthcare professionals to provide their feedback about whether they can improve the cost of care by having visibility into patient nutrition. And over 95% of them said that yes, it would be useful or extremely useful if they had visibility into patient nutrition. But less than 15% of healthcare professionals today have this data. So we as developers and the community that builds AI-powered apps, we've got this very, very unique ability to close this gap. Think about the market opportunity here. If like healthcare in the United States is a $4 trillion industry, it's a lot. 4 trillion is a lot. And the vast majority of healthcare providers, professionals, believe that they want nutrition data. Only 15% have it. Like the opportunity scope of building those types of apps today, bringing this data to doctors is tremendous. And so the more developers leverage the tools that we provide to bring this data to the doctors and members, the more impact we will have on this $4 trillion market. So this is one of the things. Another thing that's very important. After users track nutrition, we help you effortlessly build reports. And this is very important to be able to do. So let's imagine users track nutrition using computer vision, right? So they scanned their meals, they populated their meal reports. It's very, very important to jump quickly with one click of a button and compile an intelligent report that a patient that can share with their coach, with their doctor, with their provider. I actually recently had this experience where I did my annual physical exam with my primary care provider at Stanford. And she was asking me about what have I been eating over the past few days when we were discussing some of the conditions. And I just pulled up my report and showed it to her, and she was immediately able to provide recommendations about improvements, about possible improvements and things to test. So this and this data has not been available to her and is not available to her for the majority of other patients. I just happen to have it, and it was extremely, extremely helpful. So when you are building applications using our technology, you are getting this report export capability, and you are getting this data. You can use this data in multiple ways. So imagine you are building a personalized supplement recommendation engine. If you know that your patients or your community, your members, your paying members are eating on a specific diet, and you can monitor their macros and micros, but also the SDK returns micros. You can drill down and see, for example, are patients missing vitamin B? Maybe they're on a vegan diet and they're missing vitamin B, or maybe they're eating too many foods with saturated fat and things along those lines. You can start providing personalized nutrition guidance, but you can also provide supplement recommendation. For example, if you're seeing that your member base is lacking vitamin B12, you can provide them with the vitamin B12 supplement. That gives a very, very lucrative business opportunity. Once you build an AI agent that monitors patient nutrition, that talks to the patient, helps them log meals without typing, makes it exciting, then you can start transitioning into the business component of this. And on the basis of these reports, start providing nutrition and supplement packages, start providing grocery shopping lists and other things. And another thing that just becoming so exciting today is the merger of computer vision and AI and augmented reality. Here you can see just a very simple implementation that is embedded into our SDK, where we can lock in foods in 3D space and provide fun information over it. You can imagine using this for recipes or for videos and other things. What we are able to do right now is do this with phones, but in a not so distant future, it will be possible to do this with augmented reality glasses, and that's when even more fun will be happening. So this is kind of the last usability technology that I believe will be very exciting to many members, and is enabled by on-device real-time computer vision. If you are building apps for influencers, so Instagram influencers, there's a lot of people who are logging what I eat in a day and building kind of personalized tutorials about recipes. And we developed with our SDK a very fun and easy scanner that kind of creates a recipe right in front of you on your screen for what I eat in a day. And this is only possible with real-time on-device computer vision. So from here, I wanted to shift and talk a little bit about technology side of this, is how it's all happening. So we're obviously, as a part of the DeepLearning.AI community, we are both bringing these technologies into the world, but we're also developers. We're building AI every single day, from on-device computer vision, voice interaction, AI-driven UX, augmented reality. This is all we're building here. And our CTO, James, and Ishani will talk a little bit about our Edge AI architecture, what we're doing, why Edge AI is important, and how you guys can leverage the Edge AI technology to build your own applications. So James, let me hand it over to you, and yeah, please guide me. I will scroll the screen for you.
Okay, thanks, Dmitry. Yeah, so I wanted to, as Dmitry said, we'll talk about a little bit what's going on behind the scenes in the SDK and how we are able to do what we do on the edge, which means running on the phone. So our food recognition neural networks are able to recognize over 4,000 what we call visual labels. Okay, so the visual name of a food. And what that means is that there will be certain foods like apples, oranges, and bananas where we recognize the exact food that you're looking at. But sometimes there is a limit to how far you can drill down just through visual information. So we might recognize milk, and then we have to also realize that that could be whole milk or soy milk or almond milk. So we built this huge taxonomy so that we can link visual labels to actual foods that you can log in your diary with nutritional values. So that maps 4,000 visual labels to over 30,000 actual foods. And we have a smart UX that allows people to kind of very quickly select the right food based on the visual label. So this taxonomy works in two ways. It works to link visual labels with foods, but also we need to link our neural network to this taxonomy. So one of the ways that we do this is we convert, so this image on the right hand side, sorry, is a visualization of our taxonomy. This actually is how it looks if you visualize things in a 2D way. And what we do is we flatten this out when we're going to train the neural network, and we turn it into a tree. Maybe Dmitry, if you could scroll on to the next slide, that might show it a little bit better. So exactly. Yeah, this is a subsection of the huge taxonomy that you saw on the previous screen. So you can see that we've got a tree that starts at the top with food, non-packaged food, baked goods, bagels, and goes all the way down to cinnamon raisin bagel. And what we want to do is we want to map similar looking items to a similar place in our embedding space, so that it allows us to, it allows the smart UX to easily switch between alternatives. So if there is a confusion between a blueberry bagel and a cinnamon raisin bagel, those things are close together in our data structure, and you can map very quickly to it. So what we do is we have a way to measure the tree distance between these two things. So there is only one parent node between a blueberry bagel and a cinnamon raisin bagel, but there are two tree nodes between a cinnamon raisin bagel and a cheese and jalapeno bagel. And if you were to go to some very packaged kind of Coke, for example, that would be a huge distance. And so we build this huge matrix that has a distance between every food, and we break that down into embedding vectors that represent a place in that embedding space. And these embedding vectors are then used as training targets for our neural network. So it means that we map like foods into a like place on the embedding space. It gives us control over how we can change things. If we don't like a certain confusion, we can control that by changing its space in the embedding space. And we also have a custom loss function for that training. It allows us to generate those embeddings, but also classify the food. And we've got to do all this on the edge. So we've got about 30 megabytes of space that people will allow us to use. That is feasible for us to download over the cloud, the new model files, that is fast enough to run so that we can run with plenty of overhead. We run at 2 frames per second in general, but we could run a lot faster if we needed to. Yeah, Dmitry, maybe if we move on to the next slide.
We could jump maybe to the slide where, since you're talking about the size, these are the performance characteristics, and we can get back to to the other components. But yeah, the SDK is about 10 megs, and with the models it's only 50 megs while running on the edge, right, James?
Exactly, and actually V3 is probably going to be smaller than that, because I believe that includes a database file. And now if we just go over the cloud to download certain things, that might even be coming down a little bit. So yeah, and with this approach that we've taken, even with those constraints of running on the edge and the reduced model size, when we compare with 350 common foods against some competitors in this space, we're seeing around about 90% success rate, which is kind of ahead of the competitors when we do this measure. Yeah, maybe Dmitry, if we look at where it works well and doesn't work so well.
Let's jump. Yeah, so these are some of the examples. Yeah, James, please go ahead.
Yeah, as Dmitry is saying, on the left hand side, when you've got a really kind of canonical image of what that food is. So those blueberries are undeniably blueberries. You know, the neural network will work really well. It will classify those perfectly well. All of the things on the right-hand side where it's a nice, clean state are good. What we struggle with a little bit and what we're working towards in the future is recognizing mixed complex recipes. This is a big challenge that we're working on actively right now. Maybe we can spot certain ingredients in there and kind of make an educated guess based on those ingredients. That's a big challenge. Packaged foods with complex nutrition facts. Our nutrition fact scanner works on US and Canadian nutrition facts labels, I believe. We'll try to expand that in the future as well with our some of our text recognition models. Also, I alluded to this a little bit earlier, but closed dishes. So this burrito down here, we could only really get to closed burrito in our visual label. But from there, we can allow a smart UX for you to quickly say, okay, this is actually a chicken burrito. So you're able to handle that in the UX.
Right. James, we got an interesting question from Gaurav. Hopefully I'm not mispronouncing the name, Gaurav. So Gaurav is asking, is it one model that's wholly downloaded, or do we have multiple models based on the hierarchy and the recognition that we described?
There are two models. Okay, so one model is an object detection model, or kind of more accurately a region proposal network that will spot where the food is in the image, which is useful in two ways, because of the way that we classify the food, we tend to zoom into the food to do the classification, and also it's useful in our amount estimation, or we sometimes call it the volume algorithm, but the amount estimation is.
That we will go on next. Yeah, we'll show some.
We'll show that. So that's the first component, is to locate the food in the image, and then we just have one model that does, from that point, you extract the food, the salient image of the food in that frame, run it through the classification model, and you get your food recognition.
This is actually a great segue for us to talk about food and volume weight estimation for food. This is actually has been an extremely exciting area of research, and that we are bringing to the table is doing three-dimensional point cloud reconstruction and building food volume estimation. Before, so Ishani can talk a little bit about our amount estimation technology, and we'll show a quick video for volume. Before we jump into AI on-device AI assistants, there was one very quick question from Jorge. Hopefully, I'm pronouncing the name correctly, about what frameworks we support. We support iOS with Swift, Android with Kotlin. We support React Native, and we support Flutter. So we've got SDKs that support basically all of the primary frameworks. All right, Ishani, let's cover a little bit. Let's talk a little bit about volume and what we do with food amount estimation.
Hey, Ishani, you're on mute.
Oh, sorry about that. So with the amount estimations, so this is the one of the challenging tasks that James and I have been working on for a long time, and we cracked this one. It's very hard to do something to create the point cloud on device. Am I right? I understand we have a lot of right now LiDAR. We have multiple cameras on a phone. But doing it, using those resources all the time can drill down on your phone. So we come up with the algorithm where it can actually do on device without utilizing so much resources on a device, and providing you almost as accurate as I would say human. It can beat the human accuracy, and plus and minus 15. I would say, Dmitry, can you go ahead and towards you can play this video. And this is one of the example Dmitry is showing you right now. So here we are scanning the on a Mandarin, and it give you the range like it's supposed to be, and it was 64 kilogram. Sorry, 64. Yeah. And you can see the 219 and that also 219. So it's pretty much beating the human accuracy. When I can look at it, then I could not say exactly how heavy it is, how much I'm eating the banana, it's how big it is. But with using the latest computer vision technology, 3D constructions, we can do it on a device. And this is something before even ChatGPT come up with something like that. So it's even ChatGPT can't say like accurately this way. So this is on device. Yeah. And next slide, Dmitry.
And if we actually look at and think about the accuracy of humans doing this, a typical human, when they do volume estimation, they are about 4x wrong. So basically, if you are trying on average to estimate how many ounces or grams of food is in front of you, the calorie estimation by an average human is wrong by close to 400%. So humans are actually very, very bad at estimating calories. And our technology for many foods, not for all foods, but for many foods, we're able to do this with the error rate of under 20%, which is like extremely, extremely good. The accuracy of USDA data is 20. And so if you are able to estimate volume with 20% accuracy, it basically gives you nearly as perfect as it gets.
Yeah, that sounds good. So yeah, next slide, Dmitry.
Yeah. So now assistant, AI assistant. That's hopeful. That probably will excite a lot of people here. We all know the chatbots are the name of the game, and we are actively bringing them to you guys.
Yeah, so as Dmitry says, this is the cherry on the top. We are also introducing the Passio Nutrition Advisor to integrate it with the SDK. And here we have a domain-based specific knowledge, like a specific diet plan, like for example, keto, kidney diet, type 2 diabetics diet, vegetarian diet, vegan diet, Mediterranean diet, and you name it, any diet that we have a knowledge base that. Also on the top of that, we are also, our system allows user to collect their personal information, like their weight, age, their log history, and their preferences. And this is very important when, very crucial for this kind of information to customize on an LLM side, because that can adapt individual goals and their progresses. For example, I'm on a keto diet, but I'm allergic to eggs. Well, keeping that in considerations, when I ask my chatbot, it would not give me anything allergic to eggs or a dietary preference, will take in the considerations. So it will give the recipe that does not include the eggs or anything. Also look at our log history for the users and provide you the recommendations based on that. So that's what it's introduced in our chatbot. And Dmitry, next slide.
Let's do it.
Yeah, and this is, you can see the small demo on the right hand side. There you can actually select your advisor, you can enter your informations, and this is your logs throughout the week. And keeping that in a consideration, you ask the questions, and nutrition advisor, which give you the answers to your questions, basically. And one of the good thing is, like, very soon we are introducing the voice command using the log. By using the voice command, you can log your food and everything, and that is one of the in the near future it's going to be available to you all. Yeah, Dmitry, hand it over.
Awesome. So we also got several interesting questions. So let me provide the answers here. So we got a question from Christopher about how do we start volume detection. There is a separate API call that supports So it's not done from start food detection. You need to make a separate API call inside of the SDK, and you can ping us, Christopher, in a community Slack channel, or or via Slack, and we will provide you with the exact lines of code in the SDK. It's also available in our documentation.
Just to jump in, Dmitry, it's only available on iOS.
It's only available on iOS right now. Yes.
Stereo cameras, which I think now every iOS phone would have.
What happens if you cut the orange up into halves and quarters? Great question. So our computer vision actually supports recognition of, let's say, foods in different states. So, for example, we would recognize sliced orange or sliced apples. We would recognize pieces of oranges as different foods. And so volume estimation will actually, and there is another question about volume estimation in this regard. So the density of sliced oranges is different than the density of a whole orange, because sliced oranges and basically orange pieces do not have the rind, which obviously people don't eat the rind. And the same is true for rice, for example. The volume of dry rice will be different. The amount, the nutritional density of white rice that when it's dry is very different than when it is with boiled with water. Basically, the moment you start boiling, the boiled rice, the same volume of boiled rice will be much less energy dense than the dry rice, because obviously the rice picks up water, and water has a significantly less calories. And so when we measure volumes and estimate food amounts, we take into consideration what state the food is in. So the grams that you will get and the calories that you will get for dry rice are different than the calories and the amounts that you would get for rice that is boiled. And the same would be true for sliced apples or whole versus whole apples, or sliced banana versus whole banana, banana slices versus a whole banana. So we do have in our SDK food volumes that account for that, for the state of doneness of the food. Hopefully this answers the question. All right. I may be actually missing quite a few questions.
There's a couple more questions, Dmitry. Maybe I can jump in on.
Please do, because I actually lost the track of many of the questions. And by the way, everybody, just thank you so much for being so participative. We are really building this for you guys, and I'm so encouraged by seeing so many questions and people using this technology to build apps. It's exciting. I'm really grateful for all of the questions and the participation. So, James, let's go ahead and cover more of the questions.
Okay, regarding the volume estimation for liquids and loose food. So there's no reason it shouldn't work for liquids, and it does work in many cases, but it is a challenge. So if you've got half a cup of coffee, for example, sometimes the volume of coffee in that cup can be kind of masked by the cup. So we need to do a little bit more modeling on cutlery and containers. Similarly for loose rice in a container, it would kind of depend on the kind of container. If it was a light Tupperware container, it'd probably work quite well. If it's in a bowl that masks the top of the rice, it might not work quite so well. But yeah, as I say, that's an area for improvement. We're not finished yet. We'll keep improving, but there's no technical reason that would stop us making that work. In terms of the spectrum of local cuisine, it is kind of mainly a Western focus, I would say, and that's another area for improvement for us to have more kind of Chinese and Eastern cuisine and Indian cuisine.
But we definitely have a lot of Indian cuisine. We've got a big part of our team is located in Ahmedabad in India. So we try to collect a lot of different Indian foods. And actually, when we go to Indian restaurants, the recognition works fairly well for Indian foods. It definitely works well for Italian and Mexican. I'm not. I would say from the coverage perspective, we probably are the best. We're definitely the best in the U.S. and Canada. Western cuisines, we're okay in England because the majority of foods that are eaten there are beer and porridge, and so we hyper optimized for that.
We have some bits in there. Yorkshire.
Sorry, say what, James?
Yorkshire pudding as well.
Yorkshire pudding, exactly. So we're good in that space. But we also collected a lot of data in India. Some data in India. We've got reasonable coverage for South America. We probably lack a little bit of the coverage in Asia, especially like Southeast Asia. But we are trying to expand that recognition there as well.
Moving on to another question about the status of bulk ingredient scanning, quickly scanning a series of ingredients. So that's kind of our ideal use case, I would say. There was some videos earlier in the presentation with the tray view where you can kind of scan, move your phone over a series of foods, and those results should populate into the tray for a user to then select. That's the ideal kind of use case, I would think. Dmitry, you're going to... you're showing.
Yeah, this is the video. So this is where it works by far the best. So let's say, imagine you're cooking a salad or you've got a plate with 3 well-separated ingredients. You basically swipe your phone and it immediately logs everything for you. That's kind of our primary use case that just works in the absolute best case for the vast majority of people who track their nutrition. And it also gives the most accurate tracking, by the way, to users as well. So yeah, that's, but as we go along, we are actively working right now on technology that is recognizing those foods even faster, so that you can just point the phone at all of the foods at the same time and they all will get logged into your log. But then it becomes trickier because many of the foods actually, so imagine here the foods are fairly straightforward, but imagine, for example, here when we're scanning the coffee with milk, you really want to log it one by one because you very frequently want to edit a recipe. Like, is this soy milk or is it oat milk, or is this a half and half, right? And the nutritional density of half and half or creamer is very, very different than the nutritional density and the nutrition of a milk of a let's say soy milk, right? And so we, with our user experience technology, we essentially support both of those use cases. And yeah, so Paolo, obviously, with computer vision itself, we don't support the synergies between, let's say, different foods, but that's essentially what you can build if you've got an algorithm that says that for a certain set of supplements, different foods are not aligned with those supplements. Let's say maybe you are taking a nootropic or some form of a nutraceutical, and it conflicts with a whole milk. That's essentially when this technology comes very handy. If you know that your patient is taking nutraceuticals or some form of a medication, and you detect that, okay, this is coffee with milk, show them a yellow flag saying, based on your medications and your conditions, you should be careful about consuming 2% milk, maybe try soy milk. So that's essentially the type of an application that you can build using our SDK today.
Well, I think we also had a question about the app itself, whether businesses are able to obtain the demo app that was showing. I think, Dmitry, we had that from Munib, I think.
Right. So after you sign up for the SDK, you do get access to the test flight, and you can immediately start testing it with both building the SDK itself and testing the demo application, so that you can test different engineering modes, different scanner features on iOS and Android. And the SDK itself, after you sign up for it, it's a self sign up on our website. The first 30 days, we are not billing you, so you basically can test it while you are experimenting with the test flight and the app and the SDK. What is the default diet? The default is that we. Oh, okay. Yes, my plate. So Ipsita already answered that question about the defaults. So the costs are now fully available on our website. The SDK itself is the base package is $300 a month, and it gives you up to 500 users. It's roughly 50 cents per user per month, per active monthly user, which basically allows any app developer who builds apps that are sold on App Store. We chose that price point to allow developers to build very profitable consumer applications, because as we know, in most consumer applications, users are charged, and users are willing to pay between $5 and $50 per month. So it gives you very, very, very high upside. If you build enough value for patients, you can be making between 90% and 99% profit margin with this SDK. Just bring enough value to your members on top of the SDK. But so hopefully this answers another of the questions. All right, so I think we answered the vast majority of the questions, and we are coming up on an hour. We would love for you guys to connect with us. We will be sending follow-up emails. We will be hosting a lot of events and development for developers, but we also have a lively developer community in Slack. So we are inviting all of you guys to work with us, use the SDK, build with us. We are excited to be providing Figma designs, the SDK, the code base, the support, the integration support, launch support. We often work with our customers to provide them with the launch support itself, where we do joint videos, we do design sessions, we do brainstorming events to make sure that we help our customers go from zero to launch with as fast as humanly possible, and get the results of that launch to be as productive for you as builders, as developers, as companies as possible. So please connect with us. You can connect with us via Passio, the link here. You can also scan this QR code in front of on the screen from you. And you all know our contact information. And hopefully we will see many of you in our joint channels and build together. We're excited to the next steps together. Thank you so much for joining, everybody.
Thanks very much.
All righty, we'll be wrapping it up. But again, team, thank you so much for the amazing webinar. Great engagement. I'm super grateful. Paolo, Jorge, Munib, Gaurav, so many great questions. Christopher, Fudia's team. We're super grateful for your question. Nick, we're grateful for your question. We're grateful for your participation. Looking forward to working with you. Alrighty, and we're done for the day. Take care, guys. Bye-bye.
Brilliant. Thanks, bye.